Good morning. I hope everyone enjoyed the dinner last night, and I hope that you are careful with the wine, because they kept coming. But yeah, it's early, it's 9 o'clock, and we are starting with the first session of the day related to the HAL application, and this is about the new integration and interoperability features of the HAL application. My name is Alexandru Taun. I'm a software engineer, and together with my colleague Clemens here, we're going to take you through some of this subject. If you have any questions, please keep them at the end. We'll answer all of them. So how are we going to do this? Well, first I'll talk to you about new improvement for the HAL to COS. Then I'll talk to you about the OCX export. I also did that last time. And at the end, we're going to go to the big topic of Napasteel integration. And then Clemens will take over and will talk to you about new outfitting integration features and new developments related to the 3D design and coordinate system, and as well as something extra at the end you will see. So now I would like to say goodbye to Clemens for the next 25 minutes or so. So the first topic, it's about CGF files conversion from HAL HDX. So yeah, this part will have a lot of abbreviations. Please bear with me. This is also a feature for customers that have already this integration. So the basic idea is that for the previous HAL HDX to communicate with the plant modeler, this was done through these the geometry files called GDL, the GDL format. However, now with the new HAL COS, this is done through the new format called CGF. And yeah, well, in 2022 T1, this feature came that was creating the CGF files for HAL COS from the geometry database. However, this geometry database in HAL is not really actively used anywhere, so it's not kept up to date. So, of course, in order to run this feature, you need to update the geometry database. And customers complain that this takes a long time. And by a long time, I actually mean quite a long time. We did a test with a big project, and we saw that this would take around a few hours per block. And in a project with 100+ blocks, that would be a few days. So that's not good. So then we decided to create a new tool, which is available starting with 2024 T2R4. And this tool creates the CGF files from the GDL ones. This, of course, assumes that the GDL files are present. But as I said, this is a feature for customers with already the pre-existing integration. So with using this new feature, we took the time down by a lot. And by a lot, I mean to less than 10 minutes for the entire project. That's a huge improvement. The only small downside is that we saw in this project with few 100,000 parts that about 3.3% of them had an error. What does the error refer to? Well, some CGF files cannot be created from the GDL ones because the GDL format does not require such a high precision in the geometry. So, however, the CGF does, so then it fails to create these files. And this is usually the case for objects that have a much more complex geometry, such as shell plates. However, the good thing is that using this new method, you can update the project to CGF, you can add it to HAL COS, and you can distribute it to all of the users so that they continue to work in the project. And about these very little objects that have errors, well, the HAL server is going to take care of them on each machine. So yeah, that's it for this topic. Now I'm going to the export to OCX for the releases that have been since the last user meeting, the 2043 and 25H1. Now there are two schema support, so we support the old one, 286, and the latest released one, schema 3.0. Starting with the 25H2, we'll only have one schema support, so that will be the latest, which now it's in development 3.1. This is more on the technical side, but yeah, since my last user meeting presentation, where I showed, maybe some of you were there, but I gave a demo about OCX, how to export from HAL, how to import, for example, in Nauticus, and what were the results. Well, nothing much has changed in terms of user experience, let's say, but many updates have been done under the rug. So a lot of schema updates, technical aspects. One of them, for example, was at our request to support also faceplates on grids or holes, because before they were only supported on simple curves. But what has happened since then, which I would say is quite a big thing to mention, is that we have this interoperability forum, which is composed of design vendors such as Cadmatic, of course, and together with classification societies, for example, we have this joint testing effort to ensure that the user requirements are met. And to do so, we do tests, we run tests. So last year, we ran the first test round using the schema 3, and now currently, actively, we're running the second round using the latest 3.1 schema. So how does this actually work? Well, we as design vendors, we agree on a model, just some properties of a plate somewhere or something, and we all create that object in our own software, and then using OCX, we export that data, and then we report the numbers we find, some properties such as weight or center of gravity, yeah. And then the importing vendors such as classification societies, they take this data, put it in their own software, and also they report on the results. And then we compare all of these results together and see what's the common agreement. So for example, just quickly, probably don't see very well the text, but basically this is a simple rectangular plate, and we compare various properties, for example, the coordinate system of the project. And there are some disagreements in red. It doesn't mean that's an error necessarily. That means that the projects are different, so we understand more about how each vendor handles projects. But also we can have a bit more complicated case, such as this plate with a rounded corner. And we saw, hey, look, we all agree on the weight of this plate, but there's a bit of difference in how we handle center of gravity. And what's that? Well, simply because there is a bit of difference between surface modeling and solid modeling. So this is where the center of gravity problems arise. So then knowing this, we can make improvements for later. Of course, we also did more complex cases, such as this one with profiles, where we tested properties such as body directions, inclinations, angles, all of this stuff. So see, it's quite a lot of red and some yellow, so yeah, there were quite a few problems, but this was only the first round, and this saved as a base for further improvements. And if there are people interested in the room to learn more about this, there's actually, everything is publicly available. You can click on the link, well, not now, but after this, you can access the presentations and you can find the link there. So now we are running the second round. We also have a much better reporting tool called Otter. We get real-time feedback of our results and what we should improve. We are also running more tests. Last year, we ran 9 tests. Now we are running 14, and these also include some tests for surfaces, especially the NURB surfaces, where even in our internal testing with customers, we're using OCX, we found that there were problems in how the surfaces, the NURB surfaces, were used in the export. So, but we realized that we are not the only ones, that everybody has this problem. So now we are testing together to see and to improve this issue. And yeah, here I'm only showing the results of the first 3 tests, just for comparison to see that, well, now we have much better results than last time, and we just started with this. So, now getting to the last topic of my presentation, and probably the biggest one, this is about Napasteel integration. And why integration? Well, previously was known as a Napasteel import, but because it's increasingly complex, and our future plans for this feature are quite big. We rebranded it as an integration. So yeah, I'm going to talk to you about the new developments that have been done for this and what are our plans for the future. So the list of new developments, well, there are quite a few. We improved the topology results, and as part of this, we also have a much better p-curve translation. Those that have used Napa are very familiar with the p-curves.
For the question session.
Panels, so now multiple thicknesses in a plate. Topological seams, of course, have been part of this joint development. Updates also to the user interface, and lastly, added offset to stiffeners and Napa name in the logistical record. All right, quite a few topics. Let's take them one by one and see what was done. So improved topology. Well, before in, for example, 2043, this plate was imported here with an auxiliary line, and on this side here with a fixed value with a breadth of 4200. Now we have a much better topology, so we can detect the plate in view relation to this one, but also the plate in section relation to this one. Of course, this conversion, this getting rid of auxiliary lines wherever possible and fixed values has improved by a lot, but still it's not perfect. So there are cases such as this one where we had just an auxiliary line going all the way through and then here a fixed value. Now we are able to have this relation as a plate in view, but this line was split into two auxiliary lines with this radius of curvature in between. However, I would say the biggest and most visible development has been in this topology in the p-curves translation. So before, this was simply all the way through an auxiliary line. Now we have it almost fully topological. So now it comes as a collection of relations. For example, we start with a fixed value, and we have then an angle from or angle to relation that goes into radius of curvature with a parallel distance value to the deck here, and then going back up with the same type of relations. Maybe, I mean, not maybe, but we are planning in the future that also these fixed values at the edges to be converted to parallel distance to the, to this part of the plate. For panels, well, before it's very hard to see the dots here, but you can trust me that all of them say 17.5 thickness, which is normal because before we took the thickness of the thickest member, and that was our thickness for the entire panel. Also, you can see that the seams are wrong, but I'll get to that in a second. So all of these were 17.5, and after, and now in 25H1, we still have this as 17.5, which was the thickest member, and then this is 15, and the rest are 12. And of course, also the seams look better because we also improved them. Before, these were simple, just with the fixed value relation that was going across the entire plate, even crossing through holes, which is not physically possible. But now they are fully topological. And not only that, they don't even need to be straight. So for example, this is a bit inclined. This is even more inclined here. And can also be curved seams as this one. And now this is how it looked before. And now we have end relations for seams. And these support all of them, which seams can have relations to other seams, to the plate, or to holes. So now more on the visual side of things. So because of this rebranding from a simple import to a full integration, we moved the button from under the import tab in 3D Contec. So now it was before in import, Napa Steel. Now it's under Tools, and it has its own dedicated button with Napa logo here. You can see the Napa Steel integration. And under System Management, we moved from Import-Export from Napa Steel to the Projects tab, Napa Steel, and these are the same as before, so nothing changed there. But not only that, we actually made not only visual changes, but also functionality changes to the user interface. So what does this do now? Well, this is also just a quick side note. This will be available with a later H1 release. It's currently in testing. So before, you had to open the Napa interface, which looked a bit worse than this. And you had to click here and look for your database, or Napa database, open it, wait a few seconds, depending on the size of the Napa project. And then it would load, and you'd have all the information from the project. Now what it does is actually remembers the last Napa project you've opened, the last database, and it would automatically open that when you open the user interface. Of course, keep in mind that the first ever time you use this, that field will be blank because, yeah, you haven't opened anything before, so it won't know. However, there is a small catch to this, and I'll show you in a minute. If this will want to go to the next slide, yes. Since this database is opened automatically with the UI, that loading time will happen instantly, and you won't be able to use the interface for a few seconds. So keep that in mind. It's, probably as a user, it feels a bit wrong. We saw that, but we realized that actually in reality it saves you time, because it will automatically open it, so you don't have to lose that time. The loading of the database will still be there regardless of what you do. So I will show you exactly what I mean in a second. Another thing that we added is that now we have this table here, and if you select limit parts to Napa block system, in this tab, you'll see all the Napa blocks with their name. You'll see the status. This is available, but it's currently not done in Napa. So once this is done, we will transfer it to our as well. But the status is basically, yeah, I think it's up to the user, like ready for production or in development or something like that. So you will see exactly what's happening with that block. The last integration is the last time you integrated that block into Hull, and the name here is the name of the Hull block. So you can keep track of where each Napa block is in Hull. The rest will basically be the same. And now two more small developments. So before, in Napa, you can have options to add certain offsets to the end cuts of profiles. But before, we did not transfer that into Hull. So I don't know. It's OK, visible. So there are no offset distances here. So it's basically glued to the related member in Hull. So that was not good. But now we are able to add this offset, this height distance. However, there is a small catch. This will work now only if in Napa you have the profile related to an object. Because in Cadmatic Hull, this offset distance can only be added to profiles that have relation to a topological relation. So in case you have a fixed value, that won't work because, it cannot add that offset to a fixed value relation. We plan in the future to also take into account this offset when you have fixed value, but this will mean that we need to do calculations on our own side, and we're trying as much as possible to avoid that because sometimes the calculations can go wrong and then it looks like an error. So yeah, and now the last, well, it's simply as the title says, if you have a Napa object with a name, in this case, HD trans 32P, I hope you can see. Well, now it will also be available in Cadmatic Hull under the logistical tab of that object. So you have Napa main object name here. Well, to do that, you first need to add it to the logistical database layout. Otherwise, when you perform an integration, it will complain a lot that it cannot find this logistical field. So in case you missed it, you're probably only going to miss it once. So yeah, having said that, I'll show you all these new features in an actual live demo. So, OK. So since I ended with logisticals, so now we are system management. And if we go here under logistics, I hope, yes, it can be seen very well. Logistical database layout. You go here, and you scroll all the way down, and you'll see Napa main object. You can click on it and click Add. I'm not going to do that because I already have it. So it will appear here, and that's basically it. The rest will be taken care of. And yeah, now under import export, there is nothing. It's only OSX or other parts, but no Napa. And now you'll be able to see it under projects. Oh, Napa still. These are the same settings as before. Now going to 3D Contec. Also, by the way, this is my development version, so it might look a bit different than what you're used to. So don't get scared of text or. Oh, well, this is interesting. But maybe. OK. Typical demo effect, but this is not. I don't know. Well, let's see. We can continue with. So yeah, before all import, well, there's no more Napa. We go to tools, Napa. So this is the new, and it will open the database. So now you see that the cursor is loading. So that means it's loading my last open database. And yeah, this is, it's not necessarily the best experience, but you still had to wait for this database to load anyway. So. And you will know when it's fully loaded because all the Napa blocks will appear, and it will look like, yes, so there you go. So it's not bad. This is also quite a project with few blocks. So you see here that, for example, I've performed an integration, well, last week. And, oh no, actually, yeah. So that's it. And if you select the whole active block, then this will no longer be available. If you select here free limits, then this will become available, so you can select your own limits. And if there are no limits, then nothing will be available, and the entire project will be integrated. And the rest of the settings are the same. Now, I also showed this, but in the presentation, but we can also have a look again now. So the relations that are now more topological. And it's the big plate. I was a bit curious why. Yeah, so also that. And yes, and go to Hub Viewer. See if I open the right. No. Yeah, so. For example, these bracket-like plates that have that are defined using p-curves, and you can see now that they are defined by a much broader range of relations, with more topological relations. As well, if I switch here to the thickness tab, you can see, for example, that this deck has different thicknesses. So this has a thickness of 10, and it's the same plate 133 here that has a thickness of 7. And if I go back to my other project here that has some offset stiffeners, for example, this stiffener was defined using fixed values in APA, and because of this, one of the relation does not come with an offset distance. but the other because it's topological. It contains this offset. Now we also have the seams, for example, this one that has a relation to a plate and a hole, or for example, this one that can have a relation to a plate and another seam. Now, so basically that's it. I will go back to my presentation. Yeah, so this is what currently has been done, and for the future we have just the main topics. An important one is the knuckled main object handling. Currently this is available in the integration, however, this is done through the shell application, so all these knuckled panels are imported as shell plates, and because of this, all the 3D contact functionalities are not available. So for the next release, we are planning to have these knuckled panels as basically plates, not as shell plates. The integration time, this is what we define, the time between you click OK and the time the entire block is finished with recalculation. And because of the new panels, the new seams, well, and also the new topology, so now objects are more interconnected between each other, the recalculation time has gone up by a few percent. And we decided we are currently researching, and we also made some improvements just recently to reduce this integration time and the time you wait to finish the recalculation. And another one is about composite seams. So currently we support, as you've seen, quite few types of seams, but the more complex ones that have multiple relations are currently in the works. And the last topic, well, this is, as I showed you also for OCX export. In my field of work that I work in integrations and interoperability of the whole application, my biggest challenge that every time gives me nightmares is how to handle this solid, the conversion from solid to surface and the other way around. And we've seen that Napa is also, this integration is also dealing with this issue. I'm not going to go into details, it's quite early in the morning. But basically what you need to take from this is that we are currently working together this is actively taken care of, that we will handle this thickness better in the upcoming releases. So yeah, this has been my presentation. These have been the topics, and I also wanted to show you how the topics that I presented to you also fall in line with our values as a company, and how we always try to improve what the customer experience is with our software, that we always make improvements to our features, and that only by working together we can achieve success. And with that, I would like to thank you for your attention. And if you have any questions, I'll answer them at the end. And now I would like to give the floor to my colleague, Clemens. So, Clemens, please.
Thanks, Alex. Whoa, my microphone, I probably should talk a little bit softer. People knowing me know that is a common thread of me speaking too loud. What I'm going to do in the current 30-35 minutes, I'm going to take you on a small journey through some of our new and exciting features. First going through some of the topics. After that, have a small demonstration. And as Alex already hinted to, we will go to some future topics. What are we working on? So first things first. We all know that a ship is more than just steel plates. One of the other things that we have is insulation. You can nowadays place insulation material in hull. You could always, of course, create a separate material in hull and then place it as insulation or use it as insulation. what we currently allow is a different function, a different option within system management to visualize this same installation also in outfitting and have this information combined in the outfitting system. This makes purchasing, for example, installation for a specific area easier because you can combine this in a report, so all the installation from both hull and outfitting. Continuing on this journey, we'll talk about hull markings from outfitting, or marking equipment elements, other elements in outfitting onto hull plates. This can mean that you don't need all the data anymore that you previously needed. Maybe you can do with less paperwork, because the actual marking is there on the plate. Don't have to worry about where does a certain equipment element has to be placed, because you can actually just see it from the cut steel. We have a very nice tool within outfitting that looks for qualifying outfitting items and looks for intersections to those. We will also see this in the demo. Well, moving ahead, our 3D design environment has, well, and everybody that has been in our Digital Wave forum last time, 2 years ago, will recognize this picture, right? At that time, it was shown as a sneak peek, and nowadays, this is fully delivered. You're able to create shell plates from your hull viewer. There's modern navigation. There's more integrations available, and also a very nice addition is, recent addition, is this 3D PDF visualization tool that from your assembly in the hull viewer, rule-based, you create a PDF file for a quick overview of your assemblies. And then last, before our demo, we have reworked our coordinate system and default grids in the ability to reflect any grid direction. You can, for example, set a default grid per block. It's important to note, for example, that port side is positive and starboard has a negative value. And these values are reflected throughout your application. As stated, these are the 4 topics that I wanted to mention before the actual live demonstration. So let's dive in. I'll start from our complete ship model here. Everybody can, well, nicely see ship. But let's dive a bit deeper. Let's start hiding. And here you see nicely something yellow. And this something yellow is of a different object system name, hull installation. This is coming from hull directly. Looking a little bit below this deck over here, we'll notice that at this position, there is no installation below the deck. But there's a nice cabinet placed there, a chair, a table. So probably we do want some, well, soundproofing there, or some insulation to keep our small person over here a bit warmer. So let's add this in hull. I already am in a block. I have a special installation block over here that I created. I can quickly show this also from our overview. So from our building block overview, you can see that there's this off-ship installation group, and in there I have this specific block. Grayed out, and I don't know if it is very visible, is this read-only option over here. It is nowadays possible, but from system management, to set a block to read-only. So if there's certain moments in time that you want a block to stop being worked on, you can set it to read-only, and people entering the block will be in a browser mode and will just visualize and be able to see things, but not be able to change things. But going back to this installation, and it's as easy as normally creating plates. So for example, creating a plate, and let's make this, of course, a little bit thicker, 50 millimeters. In this case, I'll do it below. and let's make certain we select our installation material. Well, again, it's as easy as normally creating a plate. And you notice these thick layers over here. These are the installation material that you saw also in our complete ship model. Now, let me just create this plate over here. And you also notice that there are several profiles. And of course, you are always able to create special user-defined profiles. And one of the possibilities there is, of course, with this special material, to have installation material around the profile and place that, well, quite easily. So I have created one called HP installation here. Maybe we'll use our grid values here to create a couple of them. And you see that the default material set to the installation material. Let me create the first one, second one. And let's do the same over here. Just making certain that we have something more to show. And this quickly lays this installation material around these profiles. Let's also start our hull viewer for this block. The system is still busy creating these models. I'll just close it. It will work on the background for us. We don't have to wait on it. And as you can see, this is the material that we have created, the installation material. But of course, this is around a specific block. So maybe we can visualize that block as well. So let's open. The real block is the 2, 3, 4 block. Let's say the steel construction block. Let's apply. It's still working on some changes here and there. And now both of these blocks are, of course, loaded together. But maybe visually this doesn't, well, make it very clear what is the installation and what is not. Well, you can, of course, define one of your logistical rules here, and making it very clear what your installation material is and what is your regular steel material. And here you see I've used similar colors, yellow. You can do something else. And you see it nicely is around this HP profile. And same for the shell plating. And as this looks good, I want to also have this, of course, in our complete model. So let's save the construction. Making certain everything is synchronized with both our hull and outfitting. And let's load our updates over here. Now you see there's some new objects, which is great. And you can see that now we also have this nice plate. As you noticed me saying, there are possibilities to create reports. And I created one that will show both hull and outfitting installation. Let's generate this report. And this is the special report we made. Let's make certain we select all installation with a specific query. And say OK, and you see, of course, the system will check out everything. It has found all the installation. We'll press Enter. And the Excel file is generated on the go. It will be opened. And here we have our hull and outfitting installation reports material list. Yeah, you can see the first couple of parts are all in the hull installation system. The material is this SL720 that I used with some sizes and dimension and some mass. And you also see a total mass. With outfitting, it will select both the installation as well as the parts that have the installation. But you can, of course, easily select only on this installation material. For example, the SL720. And we get some exhaust with rock wool installation around it. And the total mass of only these elements together. Making your purchasing and ordering a lot easier in the end. All right. Having said all of that, I will move on to the next topic, which is about this hull marking. So outfitting items, placing equipments, and putting certain, let's say, markings on the hull plates. So I'm going to place an equipment over here. This mooring winch. Let me just place it somewhere here. And of course, we can also use our existing integrations by placing the same equipment also from hull. This has not been anything new. This has been developed for already a long time. But still, it's nice to show this. Let me select it from this screen and move back here. And you see it is positioned at the current control. I could have put the current control over there. But this is not a problem because this is not saved yet. So you can just move it to wherever you want. Press your save button. I used Control S here, out of habit, unfortunately. But you see that this is saved. You see the color is changed. And that means that it's also already in outfitting. So if I would now again load the updates, you will see a new object. And it is there. Okay, let's also make certain that we can check out this object. For the markings to work, the objects need to be checked out. So let's make certain we have that there. And then start this hull marking tool. Tool, hull marking. If people paid close attention, you could have seen that this is block 2, 3, 4. So let's make certain that we select the same block and check for collisions. What happens now, the outfitting, and as you see, it's very quick, is checking any collisions with hull and other equipment. Some would have contact. Some are incompatible. The system all lists this for you. I now listed this on the outfitting object name. You can multi-select in this and say mark. And then you have the marker string over here showing, well, basically what will be also on the steel plate. So let's mark all of this together, say OK, and we also get this in the list over here. This list is kept, so for example, I know, and let me first show you as well, that here, at this position, roughly, let's see how I go there, there are some cable tray supports. And with these supports, there are small plates acting as well, positions to weld this on. And also these have been set to mark. And of course, these winches are on top of the deck, so we will see that also in our production information, that they will get an additional remark as other side, as most markings of this deck is on the opposite side. But for this one, it is of course also on the same side. But as I said, you can actually see this, so let me open the tool again, go to this block, it's 789, and there you see that these rounded triangle plates are marked with supports. Well, let's save this information to COS, so that also our hull system can actually use it. And let's update this view. Let me go here. Let me use the regular update also with outfitting items. So to make certain that we also see the equipment over there. And there we are. Let's code this plate. And the system is processing all of this. And it is using these different plates under this winch to mark. This is also under the winch. We could show that, but... And for this block 789 that I talked about, for these cable tray supports, it's also there. So let me show this as well. You see already that these are also here in the view. as a visualization, encoding the deck, you will notice that these are there, with the marker string as support. Everybody that, well, I try to keep you a bit sharp. I know it's early morning still, and yesterday might have been late, but there's some shell plates missing over here. And, well, typically, the ship doesn't like that so much. At least these big gaps wouldn't want them. So let's create those. And for that, I have another block prepared. Now let's go to our shell view near the propeller. Also start our hull viewer, because this is of course what I want to show. We're going to create this shell plate. Let's give this a thickness of 10, default material. And right off the bat, you see that the hull viewer starts and gets activated. And you see these nice lines over here. Next to that, to the top right corner, you get our new modern view cube, our modern navigation. Everybody that has used Hull for a little bit longer knows these long options that were there with all the different views. And now we have the possibility to dynamically switch to different views, rotate, go to the top side, rotate further, and also have a reflection of what you're looking at. The other options are above, to the right, so the drawing box, the clipping, and the save views option. So we didn't get rid of any features. And this is fully integrated, as in, when indicating a line, for example over here, we can continue with indicating the lines that are here on the screen. And as you see, it is nicely added to the list. So we can then just press OK, and the shell plate is being created. You don't have to think about this. And this makes visualization of these shell plates easier. It's always three-dimensional, of course, but you need to have more of an interpretation if you look at these. And now, well, you might be able to do that without. This dimension line is now currently not visible, but you can, of course, make this visible as well by just activating this on the, for example, starboard side alone. And then also, again, recreating this shell plate. So let's nicely finish this. Clicking on the different lines over here, this one. And as you can see, it's easy to select. You can also hide certain lines if you want to, and well, have a nice representation. So let's do the last one here. And you see it's just a breeze. You easily select these, click around. Of course, in this view, it would also be easy to do, but this also allows you to do it throughout the ship. You see one of the shell plates floating over here. You don't see lines now, because I limited the block area. But if I would have a bigger block area, you would have seen the lines there as well. And you can basically also indicate the plate there, and just create it on the go. Well, of course, as always has been possible, we can still use the copy function to just mirror our current plates. So let's just mirror all of these, say OK, and have the system work on that. Saves a bit of clicks now to not have them to do them from that direction. And also on the block, that's a bit further down. There's two shell plates missing. I hit one, so actually there's one here. But we also would like to recreate these, and that is on the block 789 again. So let's just enter that block. And nowadays, it's also not needed to go into an actual shell view anymore. Now you saw me enter the block, But if I just want to create a shell plate by relations, oh yeah, in this case, you need to make certain that the hull viewer is active. And that's what this message said. Make certain that you have activated the hull viewer. So, just starting the shell plate functionality, you see there's no message about, hey, you're not in a view. And you can directly define the shell plates, even though there's nothing in the shell application available. And let's make both of them. I could create a small insert plate, but I will not do that right now. And the system is generating this. And this also allows me to show this new PDF creation function based on rules. And with that, it means that you define a template in Hull. You can set some logistical data in that template. And based on the actual, well, naming that you have been using, you can check if items apply, if items validate to be included into this PDF. And we'll just indicate to generate the PDF over here. Giving us, and you see this is ongoing right now. Let me also start our PDF viewer, or at least the one I have been using over here. This is the just created 789. You can see last write time is today. And here is what is being created. We have an overview page which shows all steps or everything that you wanted to include in the overview page. And if it's in the same level, the previous steps are grayed out automatically. So for example, for this assembly level, which is the highest one in the three, you see the first step within the second step that is grayed out, third step, and a fourth step. You see also, if I scroll down a little bit, this faceplate over here, and you don't see that in the overview. As I mentioned, this is all configurable. It is based on rules, but you can define if you want to see it in the overview or not, or just a big, well, picture here. This is checking the logistical data. So based on every logistical data field, including what is in the assembly, you can do this. If you have paid close attention, you would again see that there's shell plates missing. Yeah, I do want to keep you on your toes a little bit. And that is because, again, it is rule-based. These two shell plates are just created. But I'm checking if they're actually in a valid level. And they're not. They're completely empty. So let's use our graphical selection, drop these two as a child to the shell plate level, save it. Let me close current open and regenerate this PDF again. This is not intended as a replacement for your production drawings, but as an additional assistance, as a general overview of your building sequences. Maybe you want to use it for some other details as well. And it's a very quick way of doing this. And as you can see, this is now there. And you also see that these plates are now white. Well, why are they white? Because they're selected. The colors, as you see in the Hull viewer, are being used. And this also allows for additional, let's say, information. Because, for example, you could set this to panel coloring. Logistical filter with every panel a different color. Regenerate this. Again, last time I promise. And you will notice that the different colors are there. Nicely showing the different panels. Last thing I wanted to talk about is this other grid, or the possibility to set a different default grid and to use and see all the different information. That's done for this block 779. That block is on the port side. But it has a different width grid where the port side is set as positive and the starboard is set as negative. And this already reflects, for example, even that I'm now in the block 789, in the item information of this profile. So as you can see, the profile is now on a fixed width that is positive. While, also if I would look here, the same profile is also on a fixed width over here. In this case, it's of course the grid value. Well, how does that look if we actually switch to this 779 block? Let's go to the top view. I love top views in this demonstration, as you have noticed. Going here, I could update the view, of course. And right away, you would notice from the bottom corner where everything, well, let's say, is shown, your current coordinates of your cursor. The starboard side is shown as negative, while moving up, you see the coordinates as positive. Well, also for the grid itself, it's maybe good enough to see. So you see all the different positive grid values, and going down, you see the negative grid values. But this also allows, for example, to copy this profile nicely to a positive direction, and that is outside of the ship in this case. And so let's use the shift option here. Let's use just steps of B1, because that's the default grid. Let's use an amount of 5. And actually, I don't want to only do the profile. I want to, next to do the profile, which I will select like normal, I would also like to do the actual cutout. So let's visualize again in the hull viewer, current situation, and let us select these 3 cutouts, include them in the hull viewer selection, using a shift value, and making certain we have 5 of them copied. And you right away, of course, see that they are copied to the outside of the ship. We can do some short dimensioning as well, showing positive dimensions there. This concludes the live demonstration part of the presentation, but it doesn't conclude the presentation itself. As we hinted to, we want to share with you some of our future plans. What's next? What do we want to do within Hull? What are we working on? So let's say, first thing, or at least that I will mention, is the Hull Request Manager. We want to do an overhaul, or actually an implementation of the Hull Request Manager within Hull. This is under development, so everything that you will see might be different in the final release, but we're working towards this. We want to make it easier for you to accept hulls in Hull, to have an overview, set your production methods, set your acceptance states, but also to have a better visibility. So for example, the columns. What kind of information do you want to see? What is important for you? And again, to strengthen our 3D design functionalities, have more also available in the Hull viewer. Make it possible to start the Hull Request Manager there. Make it possible to select requests for hulls in the Hull Manager dynamically. And then be able to change, for example, your acceptance states again, or your production methods. Next subject, and this is, as you can see, it's not under development, it's under investigation. It's even a bit more, let's say, premature than the Hull Request Manager. But we do want to change our checkout and check-in panel. Again, we want to give you easier possibilities, better overviews. We want to update our icons, make it more clear what happens and what kind of information is there. This also allows you now, well, not right now, wait a little bit, but to give us input. What would you like to see in this checkout and check-in panel? Please let us know. Tap us on the shoulder, send us an email. You know where to find us. And for our true power users, what we want to do is put our online or macro documentation, so the Hull macro documentation online. We are working towards this. It will be available soon. We have to sort out some smaller things here and there, but this is something that will come. And it allows you for your own customizations and to easier find the possibilities around these macros. And basically, this concludes our second Hull session, and I'll let Alex walk up the stage, and, well, we're here for your questions. Please let us know. Hello, Dimitri.
Hello,
There's a
hello.
question.
Yes, where is the hand? Yes. Yet another exercise.
Yes.
Run.
It's morning, come on.
Thank you. I have a question regarding the Napa Steel integration.
Yes.
Right now, we also have problem not only importing knuckled main objects, but also main objects that are running, for example, girders that are not on a continuous Y dimension, but who are running some kind of sloped, that they do not get imported into Hull.
Sorry, can you repeat the question?
Sorry. Right now we have the problem that if we have main objects in Napa Steel, like let's say a girder or something, that are running sloped from one Y direction to another Y direction, that they do not get imported into Hull, only if they are straight.
I think it's better if you send the project to us and I can look into it.
Yeah, okay.
So to answer it top of my head, it's...
Okay,
but it also depends the other version. Like as I showed, there were quite small steps so far, but with starting with H1, there's been quite a big step. So I hope that some of that issues have been fixed. But if you have a case like this that doesn't work, please send it to us.
Yeah. And another question is this block limits table from Napa Steel, this BLIM table. Is this taken under consideration when you import blocks?
Sorry, it's very hard to hear because the speakers are
okay,
that way.
then I will...
Okay, come here.
Is the block limit table, this BLIM table from Napa Steel, is this taken under consideration when you import blocks? Because I know you can define blocks just by frame limits or X and Y or Z limits.
Yeah,
and in this BLIM table, you can extend these limits for some kind of objects, maybe for shell plates, which should be cut 100 millimeters above the deck and that thing. There's a special table for this in Napa Steel, and
the special table I don't know, but now so before not this, but some time ago the block limits were simple box like simple fixed values, but now we take even more complex block limits. But the limits we don't define ourselves; they're coming from Napa.
Okay.
So depending on what kind of limits you want to use for your block, that limits they are given to us.
Yeah. Okay.
So if you have a more special case, as you said, maybe send it to us, and I'll give you a card after, and you can mail me about these specific topics.
Yeah. Okay. Thank you.
All right.
Who else?
Any hands?
Hello. Oh, sorry. Hello. I really want to know about this Hallviewer variant to export PDF. I really need it right now. Is it possible to use it somehow to 2023 version?
No, the 2023 version, this has been included in 2024 T3, if I remember correctly. So in the 2023 version, I think this will not be available, unfortunately.
Yeah, but really nice.
Good, good.
Thank you.
Clemens, what about the development for real 3D PDFs? Not this excuse, this 2D PDFs.
I didn't hear the question so well, so maybe I should also walk a bit
Should I
down.
speak a little bit louder?
No, it's also the orientation of the.
Yeah. No, I'm asking, what about the real 3D PDF development?
The real 3D PDF.
Yes.
What is
This PDF sounds.
You mean with the work breakdown 3D functionality? Yeah. Well, there has also been work done the last years on that. You have also seen something in the. Oh, I don't know why it doesn't work.
Check.
Check. Okay. Yeah, because I remember we spoke about this in Prague. So it's a long time ago, and I'm still waiting for it. So guys, hurry up.
But yeah, maybe we should talk afterwards because I don't think I completely understand what you're currently missing. We will. Yeah, no worries. Maybe we'll take a new one, and in the meantime, I could come to you and then I'll just repeat your question. Yep. Yep. Okay, so the question is if it's possible to have labels in this Hull Viewer, well, 3D assembly export. It's not possible to set labels per part, as you would normally, well, have in production drawings. As I said, it's not a replacement for that. You can put certain information on the PDFs. So that is rule-based, so it depends on what kind of data you have. For example, you saw in the PDF itself that there is a title, and that title is based on logistical information. So you could, based on that, and you can add additional information to that list. But it is based on the assembly step. So yes, you can have certain logistical information there. But yeah, dependent on your use case, I don't know exactly what you would like to have. So that it would be something to check out then also for you. Yeah? Yeah. So the question is, what is rule-based in this context of this Hull Viewer? Some of you might know, I hope most of you will know, that there's already rules in Capmatic Hull. With the rules, you can, for example, set certain reports, set certain information in reports, and list them out differently. This PDF system is using a similar mechanism of rules. The actual position is a little bit different. It could be talked about later. Basically, what you want to do, you want to tell the system, okay, this is the assembly step I'm in. This is the level of that assembly step. And, well, as I said, you only want filled out information visible in this PDF, for example. And then you can say, okay, if this information is filled out for this step, then I want to include it. And otherwise, automatically it will be excluded. That is what rule-based means in this context. It is also in our documentation currently, so you can look it up. Does that answer your question? Great.
Yeah, the mic is working. And regarding the previous question about 3D PDFs, as a product, we're looking into making it even more 3D oriented, so any ideas are welcome. Anyway, we will consider them, and somehow, more or less, it can be implemented in more 3D, nicer thing.
Good morning, Clemens.
Hey.
Multi-engineering, Evgen Snopek. I have a question regarding your installation part of presentation. I've seen that already there was some layer installation for the shell plate. Was it created like a separate shell plate, I suppose?
Yeah.
Yeah, okay. And another question for the profiles installation. The solution that you just shown is also like user-defined type of profile per existing Holland profile inbuilt in the Cadmatic, right?
Yeah.
So basically we still like a bit, let's say, limited with the, so basically we have to still define user-defined profile, and it should be done by system administrator. So it will be included in some new update, or it's still like things that should be done by sysadmin locally?
Yeah, currently that is the case indeed. So that you still need to define this user-defined profile. It's not a built-in feature because, again, your specification might differ from somebody else's specifications. Maybe around this profile you want thicker walls. Also, of course, dependent on ship types, rooms, etc. So very hard to, let's say, have a default option there.
But anyway, that's good that you are moving in this direction. And I think I've contacted you recently, maybe 1 year ago, regarding installation stuff. Yeah, so maybe, that's why we started with.
Yeah.
Okay, thank you.
Absolutely, this is a great point to start from, I would say.
Indeed. Yeah, good. Thank you.
No problem. More questions?
Yeah, I want to ask more about this installation. I saw you make report in Cadmatic outfitting,
Yep.
but maybe I miss in Cadmatic hull. There exists some report for this installation?
Yeah, of course, you can, in Hull, you can create reports on everything. If you just want to have only the material that I used, which was called SL720, in a report, you can do that, of course. It's just a material type like everything else. So if you only want the Hull part installation, that is also very easy.
Okay, and we can get weight for this, bill of material for this, let's say?
Yeah. So what I did in system management, as a bit of a background information, I just created a new material type called SL720. I changed the specific gravity to the specific gravity that you would use for this kind of installation material. Of course, you have your, let's say, lists of, insulation and what kind of weights do they have. So based on that, I changed the specific gravity, and then you get the real weight there. So yeah, absolutely, that is possible.
Okay, thank you. One more question for shell plate development. You shown that we can select hull lines in hull viewer. Is it possible mix hull lines in hull viewer and coordinates in hull?
Yeah. You can mix and match, and I think with the first shell plate I showed, I also saw me in 3D in the shell application, click one of the lines, and then continue in 3D. So yeah, absolutely. Also fixed values, you can do that very easily.
Thank you.
Problem. Anything more?
This is a question probably on the developer side. I know with the 2024 T3, the protocol that Hull is using is still SMB2. Is there any plan to upgrade this protocol to a newer one? Because our network team doesn't like using SMB2. They wanted to use a newer protocol, probably SMB3.
Sorry, I didn't. It's for me or for?
I think it's for Dimitri, but
So far, any plans to change, but please send an email and we can, as we discussed. Yeah. Not right now. Yeah.
Nobody? You now have the chance, and otherwise we'll finish this off early and go for coffee.
Yeah. Well, thank you. And if you still have questions, you can find us after. And
Yes, please let us know.
Don't hesitate to come to us.
Well, I hope the coffee is served, so.
Thank you.